This is day 5 of Matrix Life. So today we're going to do a really easy thing called transposes. A not very hard thing with 2x2 inverses, and then a pretty hard thing with 3x3 inverses. The homework will feature, I think, one 3x3 inverse for you to do, but that's going to be a spectacle in a minute. But first I'll tell you there's a thing called transposes. The word transpose is an English word. It means something. If you know that definition, it might help you figure out what I'm doing. But every matrix has a transpose. It doesn't matter what shape it is. Every matrix in the universe has a transpose. So let me do this one, and then we'll see if you can tell me what I did. So if I want to do the transpose of this second matrix, this little T that looks like a power has nothing to do with powers. It just means I'm doing the transpose. Chalk is fading. 6. So this matrix transposed is this matrix. Can anybody explain what happened? Sort of. There's a more like in-depth sort of way to explain it a little more clearly, maybe. Everybody see what happened? What's this called? That's a row. That's a column. Explain to me in terms of rows and columns. What did I do? I made the rows into columns and the columns into rows. So what used to be the first row became the first column. What used to be the second row became the second column. Or if you prefer to look at it this way, whatever used to be the first column is now the first row. Second column is second row. Third column is third row. The rows became columns, the columns became rows. That's all that did. What shape was this one? Who by who? That is a 2x3. So the transpose of a 2x3 is going to end up being 3x2. Question about concept of transpose. So this is a 2x2. If I transpose a square matrix, it's still going to be a square matrix. Who's in this spot? 1, 3. Question about transpose. Inverses. You have to be a square matrix to have one. So on the homework, I think there's some problems where I might give you a matrix like this and say, find the inverse, and you would just quickly say, I can't. No answer. That's fair. But if I give you a square matrix, it's possible that these square matrices may have inverses. It's possible they may not. We'll see if we can tease observations out of people. But the inverse of a square matrix will still be a square matrix. This one, it's a little deceptive because there's double ones in it maybe, but I'm going to go 1, a -3. I'm going to do a -1 and a 4. That would be the inverse of that matrix. There's some sort of pattern that I just conducted. That's what I did, but with the double ones, maybe it's hard to sense what I did. So I'll do another one, see if anybody can sense what I'm doing. Here I'm going to go with a 1, a -2, a -2, and a 5. And again, there's like a pattern to how I'm going about my inverse doing life for 2x2s. Anybody up for taking a stab at this one based on a trend? That is a 2. That is a -5. That is a -1. You got it. Can anybody other than him explain what in the world was just happening on that sequence of stuff?
It's always like the left bottom and the top right always have like a negative sign.
Which ones?
For the left column, the bottom one
Okay.
had a negative sign.
Yeah.
And then 3 always had a negative sign.
Yep. Whoever's in those two positions, we're going to swap their signs. So these were positives, they became negative. If these had been negatives, they'd have become positives. But these numbers, they're just going to swap their signs. That is like half of the pattern. That's true. What else was going on other than that? The other numbers switch spots. So along, this is called the main diagonal. Along the main diagonal, we can switch their spots. And then along the other diagonal, switch their signs. I think I'm off camera when I get, aren't I? So I'm gonna need a quick turn. There's one more tidbit coming. So if I go to take on this next one, you would think 3, and you'd be mostly right. Okay, this one springs a surprise on you that we'd have to multiply all of those numbers by a half. And you think, what? We'll see if we can figure that out in a minute. For some reason, we didn't have to do that over there, or we actually sort of silently did without doing it. But here, there's this number in the front. We're going to have to multiply this by a half. I'm not going to physically go through the ordeal of multiplying all the numbers by a half. It just seems unnecessary. We create a lot more fractions than we already have. I would just go with this. If I went to take this one on, still a 2, still a 0, still a 0, still a 2, because nothing happened. If you try to swap along the main diagonal, they're the same number, so nothing happened. Try to switch those signs, nothing happened. But this has a 1/4 involved. And you think, what? Where are these numbers coming from? Anybody have a theory on where I'm pulling these numbers from? I'll say it's a number that I've taught you about in the last 3 or 4 classes that we've been doing this. It wasn't the first day, but someday in our matrix career together, there was a lesson where I said every square matrix has a number associated with it, and that number would be back, and today's the day that number came back. Anybody have a memory of a number? Every square matrix had this number associated with it. It started with a D. I think you did this homework and have it filed away in my book. I believe we had a full homework about this. Yeah, yours is presently living in my book. Other people, this is something you either communicated with me or maybe didn't do it yet, I don't know. The word of the day that day was a determinant. So, can anybody remember how to compute the determinant? Because the determinant is what's causing these numbers to happen. Memory of how we did the math on the determinant? We multiplied some stuff and subtracted some stuff. Yes, you're thinking the right thing. Multiply who and subtract what? Anybody remember who multiplied or who subtracted or how that worked? Okay, so we multiply the main diagonal, that's giving me 6. Subtract the other diagonal multiplied. So we multiply the main diagonal, we multiply the other diagonal, and we're thinking 6 minus 4 makes that 2. It's always going to be a 1 over kind of thing. So here, main diagonal 4 minus 0. So I'm going 1 over 4. So if I go to do the inverse this time, it would be 1 over who? 3. This becomes 9, -6, agreed. Question there? So follow-up question. Why didn't that matter over here? The determinants were all ones. This is 4 minus 3, 5 minus 4, 6 minus 5. The determinants were all ones. So 1 over 1 makes 1, and multiply by 1 is stupid. So it didn't really matter over there. It kind of happened in the background. So how about this one? No.
Zero.
Determinant is 0. So what's that going to do?
Make the whole thing zero.
What is that?
It just makes the whole thing zero.
No. What would you think about where we've been putting the... It's impossible. Why is it impossible? You can't put 0 on the bottom of fractions. That's no good. That's why back the original note I said some square matrices have them. I'm off camera range, but they have them. The determinant cannot equal 0. If you get a determinant that's not 0, then you can do the inverse by the scheme we've been laying out. But if the determinant is 0, you can't do it. You just have to bail. So I'll need to turn the camera up a little smidge. This next one, your best bet is check first to make sure you can do it. So if we go over there to this 2, 3, 4, 6, is it even worth trying to do it? Can we do it? No, because to do the determinant is who minus who? 12 minus 12, which is 0, so you can't do it. So we've got one more thing to do, which will be a little bit longer process, but questions so far about transpose. Every matrix has one. Rows become columns or vice versa. Inverses, some square matrices have them. You can't have a determinant of 0, but if you can do them, it's 1 over determinant, and then do the flip-flops as described. Main diagonal trade squats, other diagonal trade sines. Question about 2 by 2 inverses. 3 by 3 inverses, I'm going to have to turn the camera, do some stuff, and then return the camera. So 3 by 3 identity, or 3 by 3 inverse is going to be harder to do. So if I give you a 3 by 3, I want you to do the inverse. I slipped out the word identity because I'm going to need to involve the identity matrix. We're going to create our little dot 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 area. What do I mean by the identity matrix? That was a word I dropped a couple days back. Anybody remember the identity matrix?
Ones along the main diagonal.
Main diagonal has 1s, 0s everywhere else. So if you're going to do a 3 by 3 identity, and like I said, the homework has 1 or 2 of these. There's not much of this because it's going to be a process. You start the process by tacking on the identity matrix to what I give you. We're going to do a bunch of row manipulations over here like we've done a couple other days. Like we want to use the 1 to create a bunch of zeros. We're going to do a bunch of row manipulations, and eventually, as we attack this will eventually look like that. It can be done. We've done that before. We're about to do it again. If we do a bunch of manipulations, this can be turned into that. As we manipulate this to make it simpler, this is going to become bigger. This is going to turn into simpler, simpler, simpler. This stuff is going to turn into something new. Whatever we can produce, that is the identity matrix. No one does that with 2 by 2s, but you could, but you don't want to. Just memorize the pattern, you'll be fine. So for this, top row, I'm going to leave alone for a minute, because we like having a 1 there. We always want to use the 1 beneath it to create some, what did we say? Zeros. So this is good for now. Don't need to mess with that yet. But I do need to use the 1 to bump off the 2. How can I use a 1 to bump off a 2? Multiply by negative 2. So multiplying by negative 2 wipes this out to be a 0. Multiply this by -2, add it to that, that's going to be still 2. Multiply this by -2, add it to that, 5. Multiply this by -2, add it to that, -2. And the zeros, they just don't change stuff. So those zeros aren't going to change that bottom row. So this got a little bit smaller, that got a little bit bigger. That's just going to continue to happen. Who's my next attack? This 2. That 2's got to go. So 1, 0, -3, I'm fine with for now. Top row, 1, 0, 0, I'm fine with that for now. 0, 1, 3, I'll live with that for now. So 0, 1, 0, I'll live with that for now. But if we're using the 1 to crush the 2, how are we going to do that? Multiply by -2. So this 0 is not going to change what's below it. Multiply by -2 and add down. That's the 0 we desired. Multiply by -2, add down. Multiply by -2, add down. -1. If these zeros, no matter what you multiply or add down with these zeros, the -2 and 1 can't be changed by zeros. But this 1's going to change that. Okay, we're multiplying by -2, add down, that's -2. Question about that. I'll build another column in a second. While we're there, who's the next number now to attack in that left 3 by 3? If we're trying to make the identity matrix on the left, who is it that we're going to have to attack there? The -1. What do you want the -1 to be? +1. How are you going to do that? Yeah, multiply by, which is just going to change all the signs. I don't need a whole new bunch of boxes for that. I feel pretty comfortable, and you probably do too, just switching all the signs. Now who do we need to attack if we're trying to create the identity matrix? The 3's, both of them. So I'll go over here, make myself another matrix box area. The bottom row is done forever. 0, 0, 1 is done forever. So 2, 2, -1 is done forever. How could you use the -1? Let's kill off the middle 3 first. How could that 1 kill off the middle 3? Multiply -3. So multiply by -3 and add up. -6. Multiply by -3. Add up. -5. Multiply by -3. Add up. 3. And we'd have the 0 and the 1 still there, but we created our 0. And then we'll forget all about that in a second. Question about that. How could the 1 bounce the -3? Multiply by +3. So these zeros can't change anything in the positions up above them, so 1 and 0 are set. Multiply by 3, add up, we get the 0 we wanted. Multiply by 3, add all the way up. 7. Multiply by 3, add all the way up. 6. Multiply by 3, add all the way up. -3. That is the inverse of this. And sadly, there is no other way to get that. There's no way you could just like, the 2 by 2 is just like, I'll flip the numbers around. None of those numbers were even over here. There's no way to really do that. The only way to do it is copy what you're given, tack on the identity matrix. As you make this smaller, smaller, smaller into the identity matrix, the simpler one gets harder, 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 and then when you're done, the inverse falls out and you have it. Question about what happened there. homework I gave you a sheet. I set it up similar to the other one in the sense that I gave a bunch of the matrices names and then asked you to do stuff to them. So 1 through 5 is asking you to do a transpose, so that's going to be pretty easy. 6, for a while, you're doing inverses, mostly of 2 by 2s. The inverses of 2 by 2s, that stops around like about 15-ish. 15's a 3 by 3 inverse, but it's a really easy one. 16, 17 you're going to work out. 16, 17 are going to be about like what I just did here in terms of process. And then I have you re-practice your multiplication skills. If you do get answers up through to the 19 level, what I have you in mind for you to do on 20 is take the original A matrix that I wrote on the paper times the A inverse that you figured out. And if you do that multiplication on 20 and for a bunch of them in a row, something should be happening. 20, 21, 22, 23, 24, 25. If you take a matrix and you multiply its inverse, something should happen. 26, 27, 28, 29 is an answer to a question that I've already told you. If you switch the order of matrix multiplication, do you remember if that gets you the same answer or does it matter? Will it get you a different answer? So that's what's going to that do for you. Do some multiplications and maybe they're the same or maybe they're different. 30 to 35 I'm taking a matrix and multiplying by the identity. Something's going to happen with those. So 30 to 35, it's an idea that I mentioned before, but 20 to 35 is basically practicing matrix multiplication, but it's retouching back on ideas that I tried to drop other days, and it's also bridging a gap into tomorrow. Again, tomorrow is going to be a bunch of inverse finding and a bunch of multiplication because somehow some stuff just fits together tomorrow of all the different things we've been doing. Question, anybody that you'd want to ask that might help future generations of video, anything?